Hello and welcome to the next podcast in the MotorDoc Podcast. As I said last week, we're going to do something a little different, probably a little more than you'll have to deal with. And this will be some of the data science-y stuff that goes with true energy analysis in a facility, especially in the ones that do not have a constant load. So variable loads, variable production, things along those lines. So most commercial facilities, most other things, you'll have something relatively constant. That makes the tools that we showed the past few weeks readily usable. So one of the things that you can do is get a hold of production information, get a hold of your utility data, and this is a real sample of utility data. We're going to use this. We're just going to graph this. Things to note: the period ending, this would be midnight to 12:15 a.m. on May 17th of this last year. Kilowatts, that's your demand, and then if I multiply that by quarter-hour increments, or times 0.25, I'll get the kilowatt hours here. So what we're going to do is we're not going to do an adding total of this. We're going to graph the kilowatt hours, and why not? We'll probably graph the kilowatts as well, but we're going to keep these in quarter-hour increments for this demonstration. I will show you what the actual true analysis looks like, especially when in this particular location we had variable loads that did not match up with the date. So they were producing so many widgets, and what we were looking for is a cost per a kilowatt hour per per widget, or widgets per kilowatt hour. You can go either direction in order to look at impact. So we'll graph this, and then I'll show you what a true analysis looks like. Now, some of the tools that we use will include Anaconda, which is, I'm using the Python version, but you could use MATLAB, you could use whatever. I do not, for a more advanced analysis, you'll find that data scientists have a tendency to not use Excel, or similar. Even though Excel and all these other guys have started adding in all these capabilities like analyze data and everything else, their version of AI, I'm still working with that, so we'll see how that turns out. But anyways, we're going to use Jupyter Notebooks. That provides the ability to tell a story. I will show you one of those stories. So we're also going to use ChatGPT, but Anaconda can be downloaded from anaconda.org. The version of Python we're going to use is 3.11. You can either get that downloaded with Anaconda or go straight to python.org and download. Right now, they just released in the last month 3.12. I never go with the direct 3.12. I wait till like the 0.1, 0.2, 0.3 after that before I start working with it, so they get the bugs out. That means people have used it for a little bit and all the problems go away. If you're not familiar with software like this, there's a number of courses out there that'll teach you Python. I would recommend, and I believe it's no charge, is the Coursera University of Michigan Intro to Python. I really enjoyed kind of following that at one point to see what it looked like. I've tried some other ones. They tend to be made more complicated than they need to be. And if you decide to go that route. Right, then ChatGPT we're going to use so we can graph this data back here. So let's go ahead and we'll start with setting up some code. So I've preset, well, I run some, I guess. Let's go ahead and start a new one. do Python 3, it's going to create it in that folder. And while that's going on, while it's thinking about it, let's go ahead and in here we're going to say the file we're going to use is mv-web.csv. So we want to use Python. Always want to put that in because you want to identify what you're going to do. To graph energy consumption in kilowatt hours. Okay, we're going to do kilowatt hours, why not? From let's go ahead, we're going to copy this from mv-web.csv. You notice I'm keeping my caps and everything else, using the following headers, Control V. Now, let's see what it comes up with, because I often find that I have to correct the code that it produces. So here it goes. It's going to produce some code. Now I can use the Bing application here, chat. I can use some other stuff. I use ChatGPT-4. Use chat.openai.com. Select ChatGPT-4, even though you'll have some limited use. It's more accurate than the other. Now the first thing I note here is it's giving me the data that I put in. That is not the data that I want. This is common within ChatGPT for it to make these errors. Okay, so here I'm going to say use mv-web.csv just to remind it. Okay, so now it should have it read that. You can see it always apologizes. You know, thank you, ChatGPT, for apologizing for not listening to me in the first place. But now I see this means df, that's data frame, equals pandas read underscore CSV. So it's reading a CSV. That's the name. It's going to be in the same folder as the software. Otherwise, I'd have to have the complete complete path to that file. Need to make sure that everything is correct here and matches the other file. Now we have this, and it's going to just produce just kilowatt hours. I want that for a reason. So let's go ahead and copy this. And seeing as this is having some trouble for whatever reason, I think I found that before. This was one I had preset and tested to make sure everything worked. So we're going to go in here and we are going to paste that code in this line. Now this is a notebook, so I can do chunks of code. So chunk of code, do something. It added all the kilowatts together over time, which didn't give me good data. So what I ended up doing here is I want just this orange line. So I said kilowatt hours, and this one will be blue. I come up here and run it, and let's see what happens. I'm going to go ahead and pause so we don't have silence. So apparently I had a few too many things running on the computer, so things are a little delayed. So I'll just pause if each time that happens. But here's the pattern for the facility. So this is obviously weekends. It looks like they did a little extra shutdown here. But in any case, you can see pattern each day and then night here. So they're obviously not working 24/7. And these vary a little bit. I could do all kinds of things with this information. such as take averages and so on. So that would be going back in and saying, okay, I've seen this. Now what can I pull out of that data? And then I can also add in things like production data. So let's take a look and see how that looks. So this is the same facility. And in this case, what we did is we've imported all of this data. We've added it all together across a period of time. And the other thing is this is one of the things that data science has to do is understand the data. So we looked at the data beforehand. That we did in Excel. We took a look and said, okay, we've got this in quarter hours. And the other data was in weeks. So we had production data by week. We had consumption by quarter hour. So what we end up doing is we then add in all that consumption. So our total kilowatt hours for the week, just directly from the utility information. So the first part is taking that in, and this would be, the max kilowatts for that day, because that will be the max kilowatts is, of course, our demand. So we want the max kilowatts for each day, so we know what the peak demand is for each day, and then we can look at a billing cycle and say, what was our peak demand over a quarter hour for the week? So that was part of the code up here. The other thing is the sum of the kilowatt hours over that week time. The next part was to graph it. So this is what it looked like across a number of months. And then that would be from 2022 all the way until last month. So then we start bringing in production information, and we link up the production information with the dates. So you can see here, this is why I did the data frame, or we actually export this as a CSV. So down here we export it as a CSV, energy and production rate. So we have these together. Now this is specific to this location, and for each one I'll do something a little different. But overall we start analyzing the data. Then we start graphing things with the data in order to figure out the best approach to analyze it. In fact, you'll notice there's a lot of work in here, but in the end I can actually shut down the code, so I only have the PDF, so I only have images and data. I can even have this export as a PowerPoint with just that data directly from here. So going through, taking a look at the differences of the different types of widgets. But the key point was we were noticing things weren't matching. When we got down to further analysis, we were able to see, as you can see, there's a lot of iterations of stuff. That's because we're doing this and that with the data to try to figure out best approaches, and then forecasting what data will look like into the future. And then down here, these numbers here, so we have energy is in the solid lines, and then production data follows. So what happens is we'll have a burst of energy, and then everything goes way down, and then we'll have increases in production information over time. That means that they weren't matching the production to the energy consumed, and there was periods after they produce something that they move it over to stock and then record it. So we'd have production going on, energy going on, and it would appear as if there was no production. So we then had to use some code to kind of shift everything over and normalize it, so that we would end up matching everything, and everything would suddenly balance out. We would be able to figure out what our energy and units were based on that production information, because they just had not recorded it the other way. That was a big challenge. In any case, this is just a sample of how complicated it can get. Now, we are going to not worry about this. Here's the good news for the future. We are going to, starting next week, I'm going to use some data, some real data, that we'll be collecting in order to come in and take a look at what the energy impacts are or the losses for existing machines. And these are going to be a series of motors from very small, I think one's a half horsepower, all the way up to very large 4160 volt machines, and identify what all the total losses for those machines look like. And in order to justify the project in the first place, to go in and say, hey, we performed this project, here's all of the energy associated with those, here's the hours we know they operate, here's the impact overall, and then we can say, okay, what's the average energy? Now, what happens if we take these and correct them all? What's the impact? And then also tie that into greenhouse gas emissions, primarily because that's what the project calls for. So in any case, that's what we'll cover next week, and I look forward to having fun showing you that. In the meantime, just keep in mind that if you want to pursue the more advanced methodologies to bring things down to energy cost per unit of production and the impact of the program, it can be a little more complex. For this, you'll either want to learn a little bit about the data science tools that are available. The most popular is Python, but there are other programs if you're more familiar. And if you don't know and you don't have the time to learn it, then I would highly recommend getting together with your data science team in-house. As a matter of fact, they might want the project. These are a lot of fun. So in any case, that's it for now, and we will talk again next week on real data. Thank you very much.